In this lesson, you will test the fully integrated IoT system that we've built so far. The goal is to ensure that all components, sensor data collection, TFT display updates, and web server functionality work seamlessly together. This involves testing the system in various environments, checking for proper data updates, and troubleshooting any potential issues that might arise. By the end of this lesson, you will be able to confidently run the IoT system in different environments and identify common issues related to connectivity, sensor accuracy, and of course, system stability. At this stage, you have a complete IoT system that reads temperature and humidity data from the AHT10 sensor, displays the information on a TFT screen, and serves it on a web server via Wi-Fi. Now, it is time to put your project to the test. Testing is a critical phase of any project. It allows you to confirm that your system behaves as expected and helps identify issues that might have not been obvious during the development process. You will learn how to systematically check your system for sensor accuracy, confirm the data synchronization between the TFT display and the web server, and troubleshoot common issues. Let's go over some preliminary checks. Before diving into some more rigorous testing, it's important to run some preliminary checks on your IoT system. These checks ensure that the basic components are working properly before conducting more in-depth testing. So let's confirm the basic functionality. Ensure that the TFT screen is properly displaying the sensor data. You should see real-time temperature and humidity readings. Open a browser on a device connected to the same Wi-Fi network and visit the ESP32's IP address. Verify that the page loads and displays the correct temperature and humidity values. Take notes on the readings on the TFT display and compare them to an external thermometer or hygrometer, if available, to check the accuracy of the data from the AHT10 sensor. Now that the basic functionality is confirmed, it is time to test your IoT system in different environments. This is done to ensure reliability under various conditions. We will start with indoor testing. Place the IoT device in a room with normal temperature and humidity. Monitor the sensor data on the TFT display and the web page to ensure consistency. Simulate higher moisture levels by placing the device near a source of moisture, for example a humidifier, a kitchen, or a bathroom. Ensure that the system responds by accurately updating both the display and the web server data. Take the device outside and test it under different temperature conditions, like during the day or night. Observe how well the sensor reacts to the change in temperature data and how quickly the data is being updated. Test the system in different weather conditions, such as a sunny or a rainy day. Remember to protect the hardware from water or direct sunlight. Monitor how the sensor handles the change in weather conditions. Test the limits of your Wi-Fi connection by gradually moving the sensor further away from the router. Ensure that the web server continues to respond and serve data to your web browser. Note any connection drops or delays in data updates. Simulate a temporary loss of Wi-Fi signal by turning off the router or moving the device out of range. After reconnecting, check if the ESP32 automatically resumes operation and whether the web server is still accessible. A key part of this lesson is to verify that the data displayed on the TFT screen matches the data served on the web server. This is known as data synchronization. As the sensor collects data, check your TFT screen and refresh the web page. Ensure that the temperature and humidity readings are the same on both interfaces. Check for any noticeable delays between the updates on the TFT screen and the data being refreshed on the web page. The delay should be minimal, typically less than 1 second, and both the TFT display and the web page should be synchronized. Open the ESP32's webpage on multiple devices, such as laptops, smartphones, tablets, and verify that all devices show the same data at the same time. Refresh the webpage rapidly on multiple devices to see how well the ESP32 handles client requests. Monitor if the web server can still serve data consistently, or if any issues arise due to increased traffic. While testing, you might encounter some issues that need troubleshooting, such as Wi-Fi connectivity problems. The page does not load or the ESP32 does not connect to Wi-Fi. For this, ensure that the credentials in the code are correct. Check that your Wi-Fi signal is strong enough. If the TFT display does not update or shows inconsistent data, ensure that the display is correctly initialized in the code and that the sensor is providing accurate data. If the temperature humidity readings appear incorrect or fluctuate wildly, place the sensor in a stable environment to minimize fluctuations. Check for any loose connections or interference from nearby electronics. If possible, recalibrate the sensor by comparing it with a known accurate reference. If the web server responds slowly or does not update the data in real time, verify that the ESP32 is not overloaded by tasks by checking the loop code for excessive delays. Ensure that the web server is properly handling requests and that the network connection is stable. After thoroughly testing your system across different environments and scenarios, you should have a good sense of its stability and functionality. Successful testing means the sensor collects and displays accurate temperature and humidity readings, the TFT display and the web server show consistent, synchronized data with minimal delays, and the ESP32 successfully connects to Wi-Fi and serves the web page without interruption. If everything works as expected, congratulations! You now have a fully functional and thoroughly tested IoT system. In this lesson, we went over how to test your IoT system in different environments and conditions. Check for data synchronization and troubleshoot common issues. Testing is a crucial phase that ensures that your system is reliable, accurate, and ready for real-world use. With successful testing, you now have a solid foundation for expanding the project further, whether by adding more sensors, increasing the data complexity, or just improving the web interface. Testing your project helps ensure its stability and performance, preparing you for future enhancements and real-world applications.